So it's just a matter of really wrapping your head around how you want to do it and what concrete actions you want to undertake. But in the end, I think it just pays off to be green, and I hope it will only go in this direction.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to another episode of This Week in Green Software, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. In this episode, we have some insights from the recent Linux Foundation Energy Summit in Paris, Microsoft issuing a code red for green coding, concrete examples of using cloud carbon footprint to reduce computing emissions. Before we dive in, though, let me introduce my guest today for this episode of This Week in Green Software. Today, we have Nina Jabłońska of EnergyTag. Nina, I'll hand over the floor to you to introduce yourself and say what you do. Go for it.
Hello. So I'm Nina Jabłońska. Nice to hear you, Chris, again. So I am the operations coordinator at EnergyTag. Super happy to be here. So privately, apart from working at EnergyTag, which is a nonprofit organization, I am also actually finalizing my master's studies in sustainable energy systems, which is why I am currently placed in Stockholm. And recently I have actually taken up Spanish classes, which makes a lot of sense because I'm based in Sweden. Yeah, my master's, the first year I spent actually in Barcelona, and I started learning a bit of Spanish just to be able to do my groceries. And since I found that in Stockholm, everybody speaks English, so I figured I would just continue this journey of learning a third language online with a teacher. But it's pretty exciting. A very nice thing to do some extra brain exercising in a bit different way than studying and working.
Cool. All right. Thank you for that, Nina. And I should probably introduce myself as well. My name is Chris Adams. I am the co-chair of the policy working group in the Green Software Foundation. And I'm also the executive director at the Green Web Foundation, another nonprofit working towards an entirely fossil-free internet by 2030. If you are new to this show, the format is as follows. We basically have some people come onto the show. We look at some stories in the news that caught our eyes, and we just talk about them and share some notes and reckons, basically. That's largely it. And we have a few stories ahead of us that I've foreshadowed already. We're going to start with the first story we have here, one from the Green Software Report. So what I've been doing for the last few weeks is I've been inviting guests to pick an insight that caught their eye. And Nina, you are no different today. I'm going to give you an idea of anything that caught your eye when you were looking at this, and it may or may not be related to what you do at work. So yeah, I'll hand over to you. What looked interesting when you were looking at this?
Mm-hmm. Yeah, it so happens that one of the stories is actually a bit related to what we do at EnergyTag, and that's the fact that the carbon-aware software, so a software that would operate in the time and place where the grid carbon intensity is low, or it would optimize its work based on the grid carbon intensity, is super important to enable further decarbonization. And we also heard a very interesting presentation from Avenad on this during the LF Energy Summit. I think the whole conversation around having software that really can optimize and choose when and where to operate, depending on what kind of sources are available in the grid, is very important.
It's about, the underlying kind of how dirty or green the energy is. Okay, so one thing from the actual conference we were both at, the LF Energy Summit, was this talk by Dan Benita and Simon. Oh, Nina, I think I might need you to help me with this because it's a long Polish name that I'm going to struggle with. Could you maybe help me with this? Is it Simon Duchniewicz? Maybe?
Duchniewicz.
Duchniewicz. Okay, one more time, please.
Duchniewicz.
Okay, great. Simon that from Avanada. That was the other deck. We can share a link to that, has them explaining some of the work they were doing and what they were using there. Okay, thank you. That was the only thing. I just wanted to make sure I got it pronounced properly, and it sounds better from you than it does from me.
The Polish surnames are... He doesn't have the weird letters, though.
The diacritics and things.
Exactly. You turned mine into just the regular L and N I can see here. But for example, on my Spanish student ID, they just turned that into a percentage sign. So official student ID said that my name is Nina Jab, percentage sign O, percentage sign Ska.
Okay, this is why people should be using Unicode as much as possible instead of ASCII.
Yeah.
But yeah, Nina Ya percentage Enska is not the correct name.
It's definitely not. But imagine going to a bar with my friends and they would check the IDs and I would just show my student ID because it was the first card that I got out of my wallet. And the guy was just like, "Are you Elon Musk's daughter?" And I should learn to make a robotic sound of my voice and just try to like say back something funny in Spanish, but I could not.
That's probably going to be easier than explain the problems associated with Unicode and ASCII code and stuff in the middle of a bar. You mentioned that you're in Stockholm right now, right? So that's in Sweden, yeah?
Yep.
And that's a relatively green grid by comparison, right? Because that's usually a hydro or wind. What would it be?
Yeah. The northern parts of Sweden especially are very clean. They're mostly based on hydropower, as you mentioned. In the south, there is still a bit of challenging situation with a bit of leftover gas generation and so on. But overall, Swedish grid is really one of the cleanest ones, which is why most of the challenges present in other countries are not really discussed here so much.
I see. Whereas
it could be a good, could be a bad thing, but they're really moving at the forefront of decarbonization of every single sector, including transport, etc.
I see. Okay. And so I'm in Berlin, so right next to the border, relatively close to the border of Poland. And Nina, you're originally from Poland as well, right?
I am, hence my complicated surname.
I see. Yeah. So that's an example of a grid which is relatively coal heavy and somewhat dirty. So the same program run in maybe, say, Sweden compared to, say, Warsaw or somewhere might be much dirtier depending on how you would run that. Although that may be changing over time because Poland turns out to be one of the fastest decarbonizing countries as of last year. That was one of the stories that I learned, which I was surprised to hear from, given how coal heavy that grid is, for example.
Yeah, it could be surprising, but it could also make a lot of sense, just given the fact that decarbonizing the first 10, 20, 30% is way easier than decarbonizing the last 30, 20 or 10% of energy demand. Of course, a lot of challenges come with balancing the grid supply, with introducing the technologies needed to cover the last really couple of kilowatt or megawatt hours of demand in various hours. So I think it is a good sign, of course. I root for my country. I would love to see coal gone as soon as possible. But I also think there is still a lot to be done. Partly, it's also nice that maybe the technological development needed to really cover this last piece of demand is going to happen abroad. So let's say maybe people from other countries and the grid operators from other countries will figure it out for ourselves and we will just follow their example in this sense. But
okay, cool. So that's one of the examples from here. So we spoke a little bit about the difference, the carbon intensity can be different. And this was one of the ideas behind kind of carbon-aware computing, for example. I guess it's one thing that might be worth asking is like, well, how do we know this is really the case? And this is something that I found quite interesting, that when we were both at the Linux Energy Foundation Summit, there was actually people talking about, okay, this is how you can build open models of understanding what kind of interventions you can actually make. This might be a kind of jump off point, because one of the panels that we saw was specifically related to this. There's a number of large companies, but there's also some work from, I think you might know Igor's surname, Dr. Igor. Do you remember? Can you help me with this surname? Yes. So he was talking about some work that the Technical University of Berlin had been doing with Google to basically model a kind of way to decarbonize all of their infrastructure between now and 2030. And the thing that kind of caught my eye was the use of an open source modeling tool called PIPES, Python Power Systems Analysis. I think that was it. I think that's something you might be a bit more familiar with than I was. And this is the first I've heard of this. And maybe you might be able to shed some light on this, because I didn't know that much about it before coming to this event, this conference. And I thought the idea that you could essentially talk about this stuff in Python was cool, actually. Yeah, I'll hand over to you, because this is something that I think you mentioned that you've been doing a bit of work with as well yourself, right?
Yeah. So as I mentioned, I am also still finalizing my master's degree. And of course, as the last part, I do need to deliver some thesis, some piece of my own work. And I actually decided to do it based on this open software and this openly available piece of code that guys from TU Berlin have written and come up with. And this is indeed part of a bigger study that they perform, which is studying the effects of 24/7 carbon-free electricity procurement on the system level emissions, but also on the emissions for those customers who decide to follow this 24/7 carbon-free procurement strategy. And then also on the cost premium of doing this instead of following the business as usual, let's say, energy attribute certificate system. So, of course, the way companies and big consumers source clean energy from the grid is through buying those annual certificates where they match their annual energy consumption with the same amount of energy in those attribute certificates that are coming from, let's say, solar power plants or wind power plants. And why this system doesn't work, obviously, is because it doesn't really send these precise signals, as we mentioned also with the carbon-aware software. It doesn't really tell you in which time and location the grid actually has a higher carbon intensity, when it has a lower carbon intensity. And it also doesn't reflect, probably most importantly, the actual cost and the actual effort that you have to put in decarbonizing every single hour of your electricity consumption. So the study developed by the TU Berlin lab is essentially doing this, assuming that some companies follow this strategy of sourcing electricity in every single hour, but also from deliverable location, meaning, for example, from the same country or for the same bidding zone. And also that this energy is going to come from additional assets. So, for example, from newly built solar power plants instead of competing with the other grid users for the existing assets. And they essentially see how that would impact the grid. And the great outcome of the entire LF Energy conference as well for me, and the great thing that I could do, is to meet Igor, who is one of the authors of the study, and who has helped me greatly with using their piece of code for my own thesis. And I just think it's so great, really, that it is available openly and we can just download it literally on our personal computers. I am not even an energy system modeler. I never created any model similar in size to this one, maybe a small one during some classes at university. So I think it's really a great thing that anybody could just download it. And it is very much, I think, encouraged also to just provide them with feedback, to challenge their assumptions, which is essentially what I'm doing for my thesis. So yeah, it is very nice for me to combine this data and software openness that we discussed also with many other people, both of us definitely at LF Energy Summit, and this kind of new generation of clean energy procurement that is proposed.
So there's there are two things that I found quite interesting when I spoke to Igor about this, when he spoke on this panel. He said one of the ideas from the work that was going on is, yes, you can get an idea that basically moving from maybe an annual approach to an hourly approach helps address some of the existing problems people have and some of the accusations of kind of greenwash related to green energy. When people say, I'm running all my infrastructure on all my servers on solar power, and they're saying this happens at night, which may be somewhat inconsistent with how most of us understand solar panels to be working, for example. There's some stuff like that. But one thing that caught my eye was he was actually saying that, yeah, by doing this, we're actually able to model the impact of whether we can make the infrastructure itself responsive. So rather than just having to make sure that we've got enough wind and solar or hydro or stuff to do this, they were talking about how they could model reductions in demand to need so much in the first place. And they're saying if you have maybe 10% of all the compute that's flexible, then you need less generation, which then will impact the kind of cost of actually us moving away from what we currently have right now, which is lots and lots of fossil fuels, to something which is greener and more humane on the grid. So that was cool. But you said something quite interesting just now about like location or like local and deliverable. And what was, is additional? Is that other thing you just mentioned? Yeah.
Yeah. Basically, if we want to put it in short words, hourly matching is not enough. So the entire study, and I think the first concept that comes into mind and that's discussed is how we want to match the supply of clean energy at an hourly basis with the demand. And as you mentioned, it's impossible in the real world to consume solar energy at night if you don't have a battery. So hourly is the first pillar that we now call them the 3 pillars of carbon-free energy. But the other two are actually equally as important as it turns out. The second one being the fact that you need to make sure that this electricity is deliverable, which means you not only have an existing interconnection between point of generation and point of consumption, but also that there is enough interconnection capacity to actually allow this electricity to flow. Instinctively, it doesn't make sense to import electricity when you're in Sweden from, for example, Portugal. The likelihood
I see.
of your electrons flowing from a solar power plant in Portugal and actually reaching for example, my house in Sweden, if I had one, are extremely low. And we actually talked to some people who are modeling this as well on LF Energy Summit. I think there's going to be a summer of many interesting reports coming. And the third pillar then is the additionality. So really seeing how it's not only enough if you match hourly and location, but also you need to make sure that if you introduce especially new additional demand, you do need to make sure that you have additional assets to meet this. And that is a huge thing, for example, with hydrogen. Because hydrogen, especially with the ambitious goals that both the EU and the US have right now, it's really an amount of electricity that you cannot just forget about. In the EU, if we want to meet the goals for hydrogen generation by 2030, I think we will need somewhere around the equivalent of the annual consumption of France.
Okay.
So it's
that's new generation, like new clean generation that would be coming in, right?
Exactly. And then new clean generation. So that's the question. How do you ensure that this is actually clean and that it contributes to decarbonization? A study from Princeton University, who are performing, we can call them sister studies to the ones from TU Berlin, from Europe. So Princeton did a study where they analyzed what would happen if you didn't ensure hourly deliverable and additional electricity. And what they found is that the hydrogen you would end up producing would be twice as intense, twice as high in emissions as the one produced right now using gas.
So that would be the opposite of what you want to have. So basically, let me just check if I understand those two things, because the idea of hourly, we kind of understand, like when people say they run on green energy and they say they're running on power and they're running a server at night, that's really intuitively easy to understand. The deliverable thing, that was like when people say, oh, I'm running my, say, websites or running a server on green energy. And what they're really doing is they are basically running it on a normal grid, but they're buying some certificates from somewhere else in the world and then saying, yeah, because I bought these certificates, that my energy is green. And the example might be, if I was to buy the green certificates from Spain, but I was running servers in the Netherlands or Germany, then it's quite difficult to actually shift electricity all the way across that. So it's a bit of a kind of porky pie to say that's green energy, right?
Exactly.
Okay, cool. And the final thing was about additionality. This is this idea that when someone's going to be saying they're running on green energy, they need to make sure it's adding new power to the grid. Because if they're not doing that, maybe you could expand on that one, because this is one thing that I think is interesting in the world of technology for us, because it looks like the whole discussions about massive new amounts of demand like AI and stuff like that, it seems somewhat comparable to the discussions people are having about saying one thing we need to do to replace fossil fuels is have a way to make hydrogen from, say, solar or wind or stuff like that. And you're saying that you need to be really careful that the power is coming from clean sources, because if you just pull it from the grid at certain times, it can be almost worse than basically getting hydrogen the usual way, which is usually coming from methane gas or something. Is that what you're saying?
Methane reforming, yeah, which is a process which I am not a chemical engineer or hydrogen expert, but this is basically a process where you directly use natural gas to produce hydrogen, which should not be the case anymore. We should really try to use electrolyzers, but if they are grid-connected electrolyzers that are going to draw this clean power from the grid, again, if we allowed them to, in a way, fight or compete with the current consumers in the grid for the clean power that is currently available, that would be a disaster, because we would end up not increasing the clean capacity. We would end up, in a way, forcing the other grid users to report that their carbon...
There's dirtier compared to what they have. I see. Okay. So there's a concrete example I think of that we've seen. So one example this makes me think of is in the Netherlands, we saw a bunch of new Microsoft wind turbines installed with some new data centers, and you saw quite a lot of pushback from locals because there's this idea that, oh, wow, there are these cool wind turbines that are in our neighborhood now. Does that mean we're going to be using green energy? And if I understand it, that power, it was additional, but it was all additional going just to the data center. So it wasn't materially changing the kind of maybe the carbon intensity of the power that you could trace to that organization, for example, even though it's forming into the grid. That was one of the things that can lead this kind of gap in perception, essentially, that people are saying, I thought those wind turbines meant that my use of power is greener. But no, that's not how it's actually being presented, right?
Yeah, that depends on which framework you use, because there's essentially two ways of reporting or accounting for the emissions of your electricity consumption. One of them is market-based and the other is location-based. If you simply use the location-based, you literally only look at the location where you're based and you take the average emission factor. And then if you do have some additional wind turbines producing clean power, then of course you're going to lower your average emission factor, which is great. But what a lot of companies do, and actually many would argue that it's a good system to implement, is the market-based one, where through the use of those contractual instruments, such as, for example, clean energy certificate, energy attribute certificates, or other similar instruments in the market, you can buy them in order to influence the amount of carbon emissions that you report, which on one hand, again, allows you to reach 100% renewable or zero emission reporting with the use of annual certificates coming from no matter what, no matter when, no matter from which kind of assets. But on the other hand, this actually does drive additional installations and additional capacity of solar and wind. It's enough to even see what the energy attribute certificates that are existing right now, what they did to the grids. They actually did, when they were established over 2 decades ago, they actually did encourage a lot of additions in wind and solar capacity all over the world, in Europe, in the US, and in many other parts. So I don't think we should cancel this entire system, but there is definitely a need right now to do the same, to provide the same extra financial incentive and to provide this extra something that's going to capture the cleanliness.
To get that recognition, right?
Exactly. And that's why we would need, for example, the certificates that would be issued on an hourly basis in order to incentivize energy storage or in order to incentivize other clean firm technologies that are dispatchable, like geothermal, for example. Or demand-side management, again, coming back to the carbon-aware software, we need a tool that is going to capture the fact that if you choose to not consume 1 kilowatt hour at night when grid carbon intensity is very high, but you choose to consume the same kilowatt hour during the day when, for example, this avoids curtailment of solar power, then that's a great thing to do. And you should aim to do so. That's it.
Oh, wow. Okay. Wow. There's a lot to it then. So if I understand that correctly, in the example here, say maybe having giant company set up some wind turbines near me on a location-based basis, it might look a little bit greener. But from a market-based basis, it might make the electricity that I get to claim as being somewhat less green, while the other organization gets to say, because we've spent a bunch of money to deploying this, we're going to claim some of the greenness of it. Okay, that does explain the two different ways of thinking about this. And yeah,
then again, just important thing to say is that, of course, we want the additional capacity, and of course, it's going to do good globally for the emissions. That's also important to track what are the global emissions and emissions in the zone, for example, in the country. And it's important also to remember that if a data center purchases, let's say, some wind power and additionally some storage in order to make sure that they have this 24/7 hourly available clean energy, this extra power that's generated by this wind turbine is also going to be injected in the grid. And then if they would report their carbon emissions at an hourly basis, they would basically sell this extra generation to the grid. So that would also globally decrease the emissions. So there is a lot of really aspects to consider here. Of course, it's not easy to predict it, but yeah, definitely it's worth to keep in mind that the market and location-based systems work a bit differently. They can trigger different behaviors and trigger different results. And I think it's worth looking at both and really taking the time to understand what they mean and what are the rules behind them and what are the equations behind the numbers, basically.
Okay, all right. Thank you for that. We've gone really deep into the rabbit hole of carbon intensity here. So should we look at the next story then, Nina? This one here was about cloud carbon footprint, this is ThoughtWorks talking about how they've been able to use this tool themselves. to basically reduce the emissions across a number of services by around, I think, 60%. And that more or less worked out to be around a saving of 46% in terms of actual cash money costs. And that seems largely, I think the phrase they're using is identify zombie workloads and switch things off. So like we spoke about before, this is literally just a case of switching things off here. But I think there's a couple of things that are kind of interesting here that might be worth diving into. There's something about Scope 3. Did that surprise you as well, Nina?
Yeah, it is very interesting because Scope 3 emissions are one of the, I would say, most challenging to track and try to estimate. So I would definitely say it's interesting to take a look at the methodology that they took to calculate this, since the emissions that we were discussing mainly so far are Scope 2, so directly from the use of electricity that you consume. But Scope 3 emissions are really the emissions around the final use of your products and then the final upstream and downstream activities around this. So I think it is really extremely difficult to, first of all, set targets, but then, of course, measure your progress towards these targets. Most companies, when they do have some emission reduction targets, they are focused around Scope 2. So definitely anything that they use in order to track those and to measure how their net zero goals could be achieved would be very interesting to look into.
Cool. Now, one thing that's also interesting with my green software hat on right now is that the cloud carbon footprint has typically used one form of measuring carbon intensity called average carbon intensity rather than just marginal carbon intensity, because the Green Software Foundation has a standard called the Software Carbon Intensity Standard that up until recently was primarily just focused on marginal carbon intensity. And we probably don't have the time to dive into marginal versus average here because that's quite a complicated thing. But essentially, the key thing that caught my eye when I was looking at this was that, you've got tools like cloud carbon footprints. Theoretically, you should be able to use these tools to work out SCI scores now for particular applications so that you can start tracking some of these and comparing them to each other, for example, in the same way that you might, say, share like an efficiency score or a grading or things like that. That's one thing that we've got some scope to move towards now for some of this stuff. Okay. Should we look at the next story then, Nina?
Yeah, absolutely. The next one is about carbon again.
This is, Microsoft issuing Code Green alert. So this one here there's two things that are interesting here, really. So one of these was basically about this idea of Microsoft making a big thing about not using water so much in its data centers or trying to move away from this and shifting to this exotic way of cooling called adiabatic cooling. And this is interesting in my view because there's been a real pushback recently about AI models, not just in terms of carbon, but also about in terms of like water usage as well here. And one thing that surprised me with this is like, there was one thing which is hidden away, basically saying, yes, Microsoft has this claim to be carbon negative, which is zero waste, and be water positive by 2030. And these were all made before there was a whole discussion about this sudden craze in generative AI and large language models and things like that. And there's a question now, like there's suddenly all this new demand coming onto the grid and all these other new discussions. And it feels very similar to the additionality stuff you just mentioned before about, okay, where do we go with this? How do we fit this in?
Yeah, there is a very interesting analogy between this extra demand from the AI-related processes and hydrogen in the regular grid, because both of these have this extra feature in them. And again, if we don't account for the extra demand that the data centers will have, I'm not talking about water, but electricity, since I'm not an expert on water use here. But this really, again, boils down to ensuring that this extra demand, no matter how big it is, which again, how do we estimate this and how do we even predict how much it can blow up in the future? It is really crucial that it will be covered with clean electricity. And again, the three pillars of hourly deliverability and additionality of these assets will be really important, again, to not turn this extra demand into a carbon bomb that's just going to blow up in our faces. Because the stakes are really high, as we've seen with hydrogen demand. And I think AI and data centers use how much of global electricity right now?
We can look up the state of carbon aware software to see what figures they have for that. That might be the best way to do it.
It's around 1% maybe, but it's still a lot.
Yes, that's still going to be So that's like half of aviation is the figure I've heard people use specifically just for data centers, not the rest of the infrastructure, say networks and things like that. So that's still, that's a medium-sized European country, basically. So that's about UK, for example. The UK is about 1% more or less, all right? So yeah, that's the kind of ballpark you're looking at, basically.
Yeah, so again, if this is the base consumption right now, and with AI, we don't really know where it's going to go and how big it's going to be. And the pace at which it has been growing recently is really beyond any estimates and any guesses. So I think we may see a similar discussion actually coming up. We've had this discussion about hydrogen. We do have the delegated act already requiring these 3 pillars in the European Union for the definition of, in order to produce clean hydrogen and to define hydrogen as green and carbon free, we need to ensure hourly new asset, no more than 3-year-old asset than the electrolyzer, and then also the same bidding zone. The same discussion right now is happening in the US, and there is more and more discussion moving towards also implementing those 3 pillars in the requirements there for the tax credit. And I think we maybe in a couple of months hear the very same discussion on how to ensure that the data centers and that AI is powered by clean power only.
You actually raise a good point, Nina, because a few weeks back, we looked at one of the stories, a report by amongst the authors was one woman, Sasha Lucioni, and she was actually in the report in the paper that she shared that we'll share a link to. There was this idea of saying, if you're going to run AI or if you're going to have these models, then what you should probably be doing is actually figure out how many hours are you going to be using this for, and then find a way to track that, because these are kinds of models which are not latency sensitive the way other things might be. So if we're going to have a model that's going to use this much power, then, and we realize it's going to create this much value, then yes, we should find ways to make sure we can run that on an hourly basis. For example, always using green energy. And because these kind of things are plausible, there are scenarios where if you're going to take maybe 20,000 hours of compute to use this, you could plausibly put them at certain times where the sun's in the sky or there's really easy access to green energy, so that you can work out what the cumulative carbon footprint of that might actually be. That's quite similar to what you just said, actually, about the whole hourly thing that you mentioned with hydrogen there. I guess the question that we might have when we look at these two things is that with hydrogen, there's this whole discussion about we need to get off fossil fuels, so we're going to need to have this much hydrogen. But we haven't really had that discussion about saying, do we need to have this much AI? Or do we need to, how much compute is enough for this? And
how much AI do we need?
Yeah, because there's going to be all these assumptions about, do we just need to do less, or do we need to meet these massive targets that we might actually have? Because the ones you mentioned before, what was for hydrogen was another France worth of electricity, for example.
Yeah, around 500 terawatt hours of electricity, which is more or less the annual consumption of France. Okay,
that's a significant amount. Wow. All right. So I guess we need to have maybe some of those discussions with data centers and talk about how some of that works, what the priorities might be for some of that then as well. Okay.
Exactly. And also one more thing that just popped into my mind is, I remember there were some people even pushing against the development of AI. And I remember one of the ideas was to tax AI companies like 98% or something from the revenues, in order to just really limit, I'm sorry, I don't remember who exactly said that, but there was an idea that if AI is going to really develop at this pace and gain so much revenue, then maybe they should just pay a ridiculously high tax in order to limit this in a way. And this gets me to think that if AI is going to be a business where you can make a lot of money, why don't you make sure that this money actually goes in a good place? And in this sense, and the same conversation again goes into hydrogen. With hydrogen, you are going to have subsidies. You're not going to just generate hydrogen and pay 100% of the price on your own. There is going to be large subsidies in both EU and US. And therefore, there really is no excuse to not make sure that you have this additional deliverable hourly clean power, and that you really don't use only clean power from the grid. Because you have the money, you have the technologies are available largely. We do know how to do it. So the question is, where is
the priorities that you want to have for this?
Exactly. And where either the legislation or the push maybe from the society is going to be to really make sure that it's doing way more good than it's going to do bad.
I see. So that's like a discussion about Okay, if there is all the value being created, how is that distributed? That's a discussion that
Exactly.
needs to be happening there. Okay, all right. Speaking of this, we've just got one more story, I think, to look into before we wrap up with with a little question here. This is actually a story from AP News about actually staff. This happened last week, actually. This was Amazon workers. Basically, they did a walkout about the company's climate impact and the return to office mandate for the walkout. This is a follow-on from us having a discussion about employee activism last week. I think it's interesting because we see a lot of the impact and lots of the action from large firms coming from employees a lot of the time.
I think it's an extremely interesting conversation in general, not only about remote or in the office to work, but also of the impact of both the pandemic and the climate crisis, and now with the new generation of workers coming to the job market. I think the reality of what you're looking for in a job has changed so much over the past 2 or 3 years. And there is power in the people. I think main outcome of this is just really, if you want to keep your employees satisfied, it's not only enough anymore to pay them well. In fact, some people are willing. There was also studies done on this, that people are willing to be paid less if they know that their companies are extremely climate aware and sustainable. Yeah.
I agree with you. This one thing that there's a particular quote. Okay, today looks like it might be the start of a new chapter in Amazon's history when tech workers coming out of the pandemic stood up and said, we still want to stay in this company and the direction of this company. This is from Eliza Pan, a former employee and a co-founder of Amazon Employees for Climate Justice. These are some of the people who've really been pushing for Amazon to be moving faster. And as an organization which is as large as it is, this is a real significant driver. That's a lot of leverage that we'd actually have there. And you see this in a number of places. And I think it's worth paying attention to some of this stuff here, because power, leverage and pressure comes from lots and lots of places. And today, as we learn more and more about the state that we're in, I think as much pressure as possible will help us accelerate and get to where we need to be, especially for 2030 on this one.
And also, not to mention that sometimes, I would even say usually, if you do the climate consciousness part right of your business, you may up even saving money, not only spending more. So it's just a matter of really wrapping your head around how you want to do it and what concrete actions you want to undertake. But in the end, I think it just pays off to be green, and I hope it will only go in this direction.
So this is interesting with Amazon specifically, because they are already the largest purchaser of renewable energy in the world now. And last year, I think they've already spent something in the region of $60 billion on infrastructure already. And this gives you an idea of the kind of scale that we need to be moving at. So this is the largest one saying you need to be moving even faster than this in order to do this. And I think for many of us, it's difficult to get our head around just the scale of these numbers and the change that we might actually be needing to do. Like you mentioned, another France worth of electricity, for example, to replace fossil fuels in certain areas. It's a dizzying times to be in. That's what I can say.
Definitely super interesting.
Okay, so we've covered through this. We spoke about some of the green coding stuff from Microsoft. We spoke a little bit about the Carbon Aware SDK. I think the last question we have now is just a final question that we have. This one is, I think this is one from Chris, our producer. If you could have any celebrity become an ambassador for green software, who would it be and why?
Is it a question coming from the Cara Delevingne, maybe?
Oh, that's a good one, actually. I hadn't actually thought about that, but you might want to explain that one, because I'm not sure how many people know about this stuff, actually. It's worth just explaining some of this.
It is so good. Of course, it has its many haters, but haters gonna hate. Basically, Cara Delevingne participated in an advertisement from Vattenfall, which is a huge company here, a huge energy company here in Sweden and in other countries as well, where she promoted an emission-free face mist or perfume. I don't exactly remember what it was, which was basically a campaign targeted at advertising the fact that Vattenfall is moving towards carbon neutrality, and they're going to create, I don't remember actually if it was hydrogen or if it was just industry clean water. Anyway, it was a campaign that was aimed to raise awareness about the climate goals of Vattenfall and the way they're moving forward with with all of this. But I wouldn't pick Cara Delevingne for green software. I think for green software, and I'm so bad at names of actors and actresses, but the guy who played in Matrix, Keanu
Reeves. Really?
Yeah, because the software, the zeros and the ones in the background, they were running like green.
And they were also green as well.
So I think he would like do the back move and avoid some carbon emissions and then have these zeros and ones in the back, and it's all green software.
So it's literally green software against a black screen. Okay, so that's your person.
For Keanu Reeves.
All right, okay. And also when things aren't working so well, we can always roll out the sad Keanu meme. So it works out on all these levels. Excellent. All right, okay. So Cara Delevingne for energy and Keanu Reeves for software.
Carbon-free couple.
Carbon-free couple, yes, indeed. All right, that takes us to the end. I think that's all we have time for this episode of This Week in Green Software. All the resources in this episode are going to be in the show notes as we normally do. You can also visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables. And finally, I want to say a huge thank you, Nina. Thank you so much for coming on for this. I enjoyed hanging out and chatting with you. And I wish you the best with messing around with Python power systems analysis.
Thank you. I'll need some of that for the next month or so. But thanks so much for having me. It was a lot of fun. A nice way to start the week.
Cool. All right. Take care of yourself, Nina. And for everyone else, thank you very much and see you on the next episode. Ta-ra! Hey, everyone. Thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again and see you in the next episode.